interrupts, esp-idf, esp32, and this is Embedded Adventure day 13, I guess. Yep, day 13, where I'm as a complete beginner in embedded systems trying to learn stuff in microcontrollers. So, in previous series we actually didn't actually code anything. We just basically learned how the interrupts works. Yep. So, particularly in on esp32 microcontroller. And today I hope we're gonna code that stuff. So, let's go. Unfortunately, I haven't brought the USB hub and the second breadboard to build a cool circuit today, but we're gonna just use the old setup. I hope tomorrow I will finally, they will finally deliver it, and I will be able to make content on this channel a little bit more, a little bit, with a little bit better quality. Yeah. Sorry for my bad English. Okay, so I'm just gonna remind you guys what have we discovered in previous series quickly, just quickly, and for myself too, just to understand. Yep. So this is basically how the interrupt system works on esp32. We have some peripheral interrupt source that can be mapped to some of the CPU interrupt. CPU interrupt is basically a combination of type and level, and, well, yeah, type and I guess priority. Yeah, type and priority. So there are some classification in official manual that we have explored in previous series. Well, I hope I will be able to find it actually. Okay. Interrupt. Where is it? Oh, here we go. Interrupt matrix. Yeah. So we have some enormous amount of interrupt kinds. This basically not the interrupt kinds, but basically a peripheral interrupt source. So and we also have the CPU interrupt that can be mapped. So my goal is to actually make the LED blink every, for example, second. Yep. And not use any FreeRTOS functions, no delay functions. Let's assume they are forbidden, and we want to just do it with plain interrupt system. So when the timer hits the 1000 milliseconds, or, well, which is basically corresponds to some amount of CPU ticks, then we call the ISR or interrupt. I haven't remembered how it translated, like interrupt what? ISR. Damn. Interrupt service routine. Here we go. So probably today we're gonna read a little bit here. Let's start with documentation. So, as we all know, the esp32 has 2 cores, 32 interrupts each. Some of them can be used, by the way, on both of them, but okay. Each interrupt has a fixed priority. Most, but not all, interrupts are connected to the interrupt matrix. Okay. Because there are more interrupt sources than interrupts, sometimes it makes sense to share an interrupt in multiple drivers. Okay. The ESP interrupt alloc abstraction exists to hide all these implementation details. A driver can allocate an interrupt for a certain peripheral by calling ESP interrupt allocate. Okay, bind interrupt status, bind, okay. It can use the flags passed to this function to specify the type, priority, and trigger method of the interrupt to allocate. The interrupt allocation code will then find an applicable interrupt, use the interrupt matrix to hook it up to the peripheral, and install the given interrupt handler and ISR to it. Okay. Multi-core issues. Peripheral that can demonstrate why shared interrupts can only be level triggered. Okay, let's go. Where is API? I just want to know how to actually register the interrupt allocate. Yep, how to allocate that. Okay, this is basically the signature of a handler. So they basically haven't provided any any suggestions here. Well, we can go probably look at the header. What's inside the header? Maybe it'll help. Basically, I'm just looking for functions that they have mentioned, like how to allocate all that stuff. Yep. I just want to quickly. Yeah, I guess that's not really cool. Let's just open it in the Visual Studio. I hope that will be more, more just convenient to do. Expressive stuff. Okay. Frameworks, I guess. It wasn't components. ESP ESP homework support, what? Okay. Right. ESP homework support. Don't have such. Oh, here we go. Okay, and let's go to headers and find the ESP interrupt allocate thing. Here we go. Okay, I'm just wanna go and find this function. Just plainly, here we go. ESP interrupt allocate. So, by the way, they should have had documentation, since they have like this doxygen type of comment. It's probably for doxygen to generate docs. Okay. Right. So we pass a source, the interrupt source, one of the ETS interrupt source, interrupt mux sources is defined, okay, or one of the internal flags or the mask of the ESP interrupt flag defines. These restrict the choice of interrupts that this routine can choose from. If this value is 0, it will default to allocating a non-shared interrupt of level 1, 2, or 3. Okay, if SP shared mask is provided, a shared interrupt of the given level will be allocated, or level 1 if not specified. Okay, then we pass an interrupt handler. The interrupt handler, by the way, let's just find it. Where is it defined? Okay, let's just simply check out the docs again. No info. Cool. Well, probably we can check them in the interrupt ESP interrupt types. So I saw that file. Let's check this out. type def structure handle data t. So that's basically a type def for a pointer to interrupt handle data t. But what is data t? Okay, handle t. No info. Cool. Well, actually they have a good docs. Oh, they had a pretty good docs on Wi-Fi topic, but on interrupts they just, I don't know. It would be much cooler to have some API things written here, but okay. High priority interrupts. Okay, let's just Google again that thing. Guess we were here. Oh, here we go. The API reference, yeah, I guess I missed it somehow. So I want to know what is that thing. Handle data t. Okay. What is it? Like, I want to check. Can I just check that, like, what is this structure? No? Okay. Not cool. Not cool. They just don't provide enough, like, description for the structures, you know. That's not really cool. But okay. ESP interrupt allocate. Okay. The interrupt handler must be null when interrupt of level more than 3 is requested, because these types of interrupts aren't C callable. Optional argument for post of the interrupt handler, return handler pointer of an interrupt handle t to store a handle that can later be used to request details for the interrupt. Okay. I just can't really understand this structure. Like, what should it, like, or it's just basically the function. Okay, let's assume that this is a function. Yeah. And we should only pass the pointer to a function to the ESP interrupt allocate. Okay. Let's just go with that. Let's go and include some stuff. Oh yeah, not here, definitely not here. Yep. So the first of all, after, of course, the necessary step of every program. If you don't write this step, your program won't work, I guarantee you, brother. Hello monkeys, and only then you can do stuff. Yep. ESP, interrupt, allocate. Yeah, well, first of all, we need to actually specify the handler itself. Sorry, guys. Again, just a little bit sleepy. So, this function actually shouldn't return us anything, and should take just plain void pointer to arc. Okay, so let's just call it the LED handler. LED handler. We will pass here some argument, which will, of course, we will not use it, and just well, okay, let's assume that this thing will remain the same in the beginning of the program. So we just resetting the pin, setting the direction to output, and then we can actually blink it. Yep. Let's of course make a static state. Yep, which will be 0. A static state. Yep, uint 8, I guess. Let it be. Okay, and set level. We can actually I will just copy the logic that we used here when we have done the HTTP LED remote control. Yep. By the way, if you haven't seen it, quite cool. I don't know, that was actually so epic that that I actually made a short video about it. Probably it's a little bit cringe, but that was too cool. So I just decided to make it. Why not? Okay, just back to code. Yeah. So yeah, we have to invert the state. Then we have to mask it because it's uint 8, and we actually have some other bits besides like the 0, 1. Yep. And oh shit. Oh shit. Yellow turned on. Oh yeah, yellow turned and the state. Yeah. That's basically guarantee us that our state blinks correctly. Yep. Oh yeah, and of course we should pass as the state as the level here. So now we should allocate that thing. Let's just find the function. We need a source, and by the source we mean that we have to specify some number. So let's just check the official documentation with all that peripheral sources, and well, that's not sources, that's actually registers, I guess. These ones are sources. Yep. These seems like sources. But these seems like peripheral sources. So like, you know, how can you take the GPIO interrupt when you haven't connected your GPIO to some input peripheral? Yeah, so peripheral basically, input peripheral is kind of a sensor or button or anything that can input information into the GPIO, and I currently haven't got any of input devices for my esp32. By the way, that's a cool idea. I'll probably should remember it. plan, yeah, plan. So probably I should rewind and make cool notes. I guess we should actually put here the shit. I should actually put here input peripherals. So like sensors, buttons, etc. Okay. Interrupt source. Well, you know, let's just open the header file. I guess we can actually find something there. Expressive frameworks. I guess that was in the same folder. That should be in the same folder. HW support in include. No. Well, where was it? SOC component. So it's like system on chip. Yeah, here we go, SOC and include. Yep. PQRS SS we there's nothing here actually. Well, maybe it's in like esp32 here. Yep, here we go. There we go. Probably it's like not the board, but the chip specific thing. So let's just find the interrupt. No interrupt source. What the hell? I thought there will be some kind of like definitions, you know. ETs, one of the defining, or one of the source defining is defining this header. Maybe I opened the wrong header actually. Maybe, I don't know. So which one should I pick? Well, I actually don't know which of the esp32 to have. I thought like this like a regular esp32. Yeah, as you guys can see probably, I don't know. It plainly says that it's just an esp32 without any prefix or anything else, so probably it should be in this folder, but it's not there. Yeah, okay. I don't know. Let's just see, maybe here we can find some interrupt sources available. No results. Same. Okay. No interrupt sources for esp32. On the same page again. Yep. Well, it should be in the docs. Yep, it should be in docs. these ones are actually peripheral interrupt source, so can't really reach them. Okay, what did ChatGPT said when it gave me that experiment? Maybe it suggested something. Okay, just gonna quickly recap what it said to me about this experiment. Yeah, polling versus timer interrupt. Timer interrupt. So the timer interrupt should actually occur. Okay. I'm doing an experiment 1. Like, what type of interrupt do timers have in esp32? Level triggered interrupts. Triggers signal transition from 0 to 1 or 1 to 0, 1 shot per edge. Signal stays high, refires until cleared. Oh, so you mean like... I guess I got the actual concept. So probably it's like about, for example, here is the signal from timer. I don't know, let's call it sig. Yep. And it's somehow fired. So it stays until cleared. And in the first case, we'll get the fire here, the interrupt here, and the interrupt here. And in the it's the first case, yeah. And in the second case, we'll be constantly getting the interrupt when we have this level, yep. So we'll be constantly getting the interrupts. I don't know with which frequency currently, but okay. Seems strange because I thought it will just, well, then if it fires only once when it hits the level, then there is no difference between them, basically. Okay. Level triggered. Timer group, general purpose hardware timers. The interrupt signal stays asserted until you explicitly clear the interrupt flag in the timer peripheral. If you don't clear it, the CPU will re-enter the ISR immediately after return. You'll get an interrupt storm. Okay. Use level interrupt reasons. Simple hardware design. Simple hardware design, well, kinda, yeah. I guess that's probably the reason. Reliable detection, no missed edges, better for periodic events, works well with RTOS tick model, very common in MCUs, it's clear the interrupt. In your timer ISR, you must do something like clear interrupt, okay. There's one shot, still level triggered, one shot interrupt stays till cleared, then stops. Interrupt clears, counter reloads, fires again later. Trigger type does not change. Still level triggered. Okay. GPIO interrupts. Age or level configurable. Okay. But what signal is exactly tracked? Like overflow signal of timer. Overflow signal of timer. Because I don't really understand. By an internal alarm overflow condition signal of the timer by the counter itself. Interrupt source is the timer's alarm. Okay. That latched bit is what the interrupt matrix sees. Is that what signal is actually tracked? Timer counter runs. Damn, I think oh god, I guess I should actually learn how timers work as well. But well, we can actually take for granted how they work in terms of the just when they overflow, they emit some kind of overflow signal. Then, when this signal reaches the interrupt matrix, we react either by the edge or by level, and then we enter the ISR. Because the prescaler, the alarm register, I'm currently not familiar with that at all. You know, yep. But okay, let's assume that we just use some kind of overflow. Yep. Okay. And we now know that timer interrupt uses level interrupt registration. So we have to clear the flag inside the ISR. So here we'll have to clean somehow the flag. I currently don't really know how, but let's just continue. Matrix CPU ISR must be cleared in ISR. Okay. I'm just gonna quickly check this function. Well, first of all, which sources interrupted timers? What type of interrupted timers have? Okay. Which timers do esp32 have, and how to catch the interrupt, or how to, you know, like register, not register, like how to allocate interrupt on one of them. And also I wonder, is it possible to actually allocate the interrupt and make it react on a certain amount of seconds, you know, so not when timer completely overflows, but when it reaches some kind of value, and then we just clear it and make an interrupt. Is it possible? So is it possible to generate timer interrupt when it reaches certain value and not when it completely overflows? Okay, esp32 has multiple timer types, each with different purposes. So we have some timer groups here. They are the ones you usually mean when talking about timer interrupts. So we have two timer groups, TG0 and TG1. Each group has two timers, T0, T1, so 4 general purpose timers. Okay, general purpose, so we basically can't use any of them for our interrupt system. Okay, 64-bit counter, prescaler, alarm, one shot or auto reload, okay, and level triggered interrupt. Periodic tasks, OS tick, and precise timing. System internal timers, used mostly by esp-idf and FreeRTOS. Okay, we probably don't need them. RTC timers, low power domain, used for sleep and wake up. Currently we don't really know anything about the sleep mode. Yep. How to allocate and interrupt on a timer grouped timer. Let's walk through the exact flow using timer group 0 and timer 0. Divider. So we somehow allocate the timer configuration. Yep. Timer pause. Sure, okay, so we need the timer. Oh, and we can actually set the alarm value. Here we go. We can set the alarm value here. That's cool. That's cool. That's cool. And by the way, I wonder what does divider does in timer? Like, what does it actually do? I actually saw that in the docs. Probably I'm gonna just see the last C chapter again, because I saw that there was some good explanation. Let's see. let's see, yo. Pretty dumb joke. I'm not gonna lie. Unsubscribe, guys. So yeah, there wouldn't be a better joke here. Okay, let's see, clock divider. Yes, I saw that, but I just didn't really got all of that. So we got the divider input, some clock pulses thing, divider output clock. Okay, what is a divider in timer? The simple things that quietly controls everything about timer behavior, while prescaler is a hardware counter that divides the incoming clock before it reaches the timer counter. It lets a fast CPU clock become a slower, usable timer clock. Why divider is needed? esp32 clocks are very fast. APB clock is 80 MHz. CPU clock is up to 240 MHz. Okay. If the timer counted directly at 80 MHz, it would increment every 12.5 nanoseconds. Yep. Seems correct. Because like we divide 1 by the 80 and divide by 1 million. So yeah, seems pretty realistic. You'd overflow or hit alarms extremely quickly. Timing would be hard to control. The divider slows this down. Okay. How the divider works, exact behavior. If input clock is F clock and divider is D, then the tick frequency is D. Yep. And the tick period is D divided by this thing. Okay. So if we take these values, we'll get the timer tick at 1 MHz, yep, and 1 tick per 1 microsecond, yep, okay. Every the input clock cycles, the timer counter increments by 1, right? Okay. ESP32 timer divider, specifics for timer groups. Divider range. Okay, I guess now I fully understand that thing. So basically the divider is the slowing coefficient that allows us to tick every 1 microsecond and not in nanoseconds. Then we have the direction of the counter. We can actually count backwards if we want. Timer pause. That's actually a genuine question, but let's just continue to see it by the docs. Yep. Just want to see that. Okay, so counter enable. Counter enable? Well, I definitely want it to be enabled. Same timer. Oh, so yeah, I get. So first of all, when we just init this thing, we want it to be paused. So we don't want it to actually count for now. Yep. Okay. That seems reasonable. So as we just allocated it, we don't want it to count immediately because it will overflow very quickly. Then alarm enable, we'll just, well, I guess we should actually put here the true. Then auto reload, yep, of course true. Then we init this thing, so we put the group, the timer, and pass the configuration. And then we've set the alarm value, for example, for 1 second or something else. But I guess here we have the number of ticks, actually. Not the number of seconds, but the number of ticks. Yep. And then we enable interrupt. Timer ISR register. Okay. So probably we don't really need this ESP interrupt allocate thing. We can actually do all that stuff through this thing. Yep. Alright, let's try this out. So we don't need that thing. We just simply make the configuration. So timer config. Then we specify different things here. So the alarm enable, all that stuff. Alarm enable, which is basically true. Then the counter enable, currently it's false. We don't want it to count immediately. Interrupt type. Well, basically it works just on the level, so we don't have to specify it explicitly. Counter direction. Count up. Yep. So counter direction is just basically 1. Oh, wrong way. Auto reload, true, of course. Auto reload, true. So it will basically just clear itself. And divider, yep, we should specify divider. Let's specify it by 80. Why not? Divider is 80. Okay. So we got the timer config, we got the alarm enable, counter enable, everything is set. So let's now set the timer configuration. Timer init, I guess. Yep, timer init we should call. By the way, we should also include some things. Probably should include something. yeah, we should include the driver timer.h. Driver timer.h. Yep. And init that thing, timer init. So we're gonna pass the timer timer group, or what? I guess timer group. We should include timer G0 or what? How it was called? Timer group 0. Yep, timer group 0. Group 0. Timer 0, of course, and pass our configuration there. So timer config. Here we go. We currently don't start it right away. We also want to register the we also want to set the alarm value, and the thing is that we should actually scale these values a little bit. So if the clock frequency is 80 megahertz and we divide it by 80, then it ticks with 1 megahertz frequency and 1 so which means that it takes every 1 microsecond. Yep, every 1 microsecond. That means that when the 1 second has passed, it will have value of 1 million. So basically we have to scale it, we have to just multiply it by 1000. Yeah. Okay. So timer set alarm value. Yep. Timer set alarm value. So we're gonna go with the same group. Group 0. Timer 0, and pass here our delay. Yep. So 2 million will be enough for the, well, of course, like 64-bit timer, I guess. It should actually be able to handle such values. Like 2 million. Oh, we have 8, 16, and 32. No, it's actually much easier to count just 2 to the power of where is the normal power here? Okay, probably can I go here? Yeah, here we go. 2 to the power of 64. Of course not. That's a huge number, so that's probably enough for the timer and for holding 2-second value. Yep. We should also enable an interrupt here. Yep. I guess this just enables an interrupt. It doesn't actually automatically enable the timer or something else. Yeah, just enable timer interrupt. So let's enable it. Timer enable interrupt timer group 0. Now I guess 0 like that. Timer 0. Here we go. Okay, we enabled the interrupt, and now finally we have to register our ISR. Timer ISR register. I'm just gonna quickly look at documentation. I'm a little bit ChatGPT phobic. Sorry guys, I'm not on the level of just copy pasting from there. So register interrupt handler. The handler is an ISR. The handler will be attached to the same CPU core that this function is running on. Alright. Timer group, timer, then we pass the pointer to our function, then we pass argument, if any, then we pass interrupt alloc flags, if any, and pass the handler to return handle. If not null, a handle for the interrupt will be returned here. Well, I don't know currently, should we have any like return value for the interrupt, but okay. Let's just register that thing. Timer ISR register timer group again 0, then timer 0, then we obviously pass our LED handler, then no arcs presented, of course, null, then allocate flags. We probably should specify some allocate flags. Level 1, well, okay, let's go with the level 1. Seems okay. And then null. Perfect. So after all of that stuff, we can finally do what? We can finally start the timer. Yep. So here is like the by the way, let's just do it a little bit more fancy. Timer setup and GPIO setup. GPIO setup. So we should not do any of that stuff. Basically, what our function will do, it just set it the all we have to do is to set the timer. Yep. So we should set the time. We should start the timer. Yep. Timer start. Yep. Timer start the timer group 0 and timer 0. Should we freed or not? Well, I don't really know. Should we DNE the timer somehow? Let's just ask. Should I DNE timer somehow? Yes, you should deinitialize or at least stop and disable. Timer pause. Memory that may go away. Disabled to use during DNA detached from the matrix. Used for entire program. Timer runs forever. Simple experiments. Well, I guess we currently don't really need to DNA it, but I will just gracefully paste it here. Yeah. Finally. Let's build it and flash it. Hell no. we forgot one thing. Did you remember what ChatGPT said to us? That it reacts by the level, so we have to actually clear the timer after the eyes are fired. Yep. When servicing an interrupt within an ISR, the interrupt needs to be explicitly cleared. Yay. Timer gen interrupt clear timers. Structure defined in here. Group struct, where n is the timer group and m is the timer number. So yeah, let's finally clear that thing with that shit. Sorry. Okay. Let's clear this. And I guess ChatGPT warned us, I just skipped this completely. Yeah. It just, as you can see, just enable alarm and interrupt status here. So yeah. Okay. Let's just try to flash that thing on esp32. I'll just simply connect this thing to the board. By the way, I probably should turn on the web camera here so you can also see what I'm doing. Well, okay, let's just make it for demonstration purposes. We'll do it later when it will work. Okay. And well, when finally my USB hub will be delivered, so I can actually plug more devices into my weak laptop. Yep. I hope that soon it will be the case. Oh shit. Oh damn. Okay, let's flash that thing. But first of all, there will be, of course, it will take some time to build. Yep. So first of all, let's build it. Build. Okay guys, I'm gonna go for a couple of minutes while it's building, just to drink some water, stay healthy, drink water. Okay guys, I'm back. Seems like some errors here. Yay. So it hadn't found the timer G0. Legacy timer group. The driver is deprecated. Please migrate to driver GP timer. Again. Oh, we should have included that thing. Yep. Should have included the timer group struct. Okay. Let's include the sock timer group struct h. Yep. Let's build it again. Timer int clear timers which has no member named T0. Int clear timers. Well, it actually should have, because the M is the you know, like the timer number from 0 to 1, so it should actually have the T0 thing here. Has no member named T0. That's strange. That's actually strange. Okay, let's again explore the header. We're doing a lot of this today. Expressive frameworks. Let's go components. Sock esp32 include sock again. Timer group. Timer. Where is the timer here? Timer group. No timer group? How could it possibly include the unexisting file here? Maybe we should actually link something, I don't know. Maybe? GPIO rag, where was it? Oh, I guess I know where was it. It was an LED blink. Let's just see the CMake list. Maybe I should ESP driver GPIO. Maybe I should have actually included some things here. Because when I programmed that thing, I was using sock module 2. Actually, it doesn't see timer group struct. That's strange. Okay, let's go GPT way. Let's go GPT way. So we're gonna just simply use some ESP functions to just simply clear the timer group. So we're gonna, well, we can actually do that in the beginning. We can actually do that in the beginning of the function, since we don't need the timer inside the interrupt handler. Yep. So we're gonna clear the interrupt status of that thing and that, and enable alarm. Like what does this? I understand like what this does, but the second function currently I don't really know what does it mean. Just quickly gonna look it up. Enable alarm interrupt using. Well, I guess it just enables it again, so this one disables it. And, okay, like what does this do. Yeah. Clear timer interrupt status. Maybe you just completely cleared all the interrupt thing for that timer. And this one just resets it. Okay. So seems good. Let's try to rebuild it. And then flash that thing and test it out. Oh my gosh. Whew, 1 hour and 6 minutes. Again, a long video. That's cool. Okay, successfully. Let's flash that thing on the esp32. Flash it. Well, I can't show you guys, but I guess that there is some problem here. No. Damn, you don't hear me, yo. Okay, so I was talking about that. For some reason, the green LED is shining. I don't know currently why, maybe some system thing. But the yellow one is connected to GPIO2. So I connected yellow to the GPIO2, and it actually, we actually can see that it does not blink. It should blink every 2 seconds. Yep, it should flip its state. But currently it's just glowing, so some problem occurred with the state, I guess, again. But here I resetted it, and in 2 seconds, I don't know, we can actually hit the timer. Let's hit the timer, I don't know, on my phone, for example. Yep. Just to verify that everything is correct. Yep, so I'm just gonna quickly press the reset and the timer, and we'll see in like how much time will it spend to actually glow the LED. 1, 2, 3. Let's go. 2 seconds. Yeah. So basically, it took 2 seconds. Well, I can. We can watch it again with like 1, 2, glow. Okay, so it works, but it doesn't switch the state. Doesn't actually switch the state. By the way, let's monitor what does it says. Maybe we haven't, like, oh, ohmmeter. Not the ohmmeter, definitely. Monitor, yep. Monitor. That type of thing. Okay. Um. Okay. Okay, what does it says? Reset. I have some problem. Abort was called at PC on core 0. Okay guys, I think we should actually make this series. This series is already long, probably 1 hour and 11 minutes. Holy shit! So probably I'm gonna end this video right now. We're gonna definitely fix that thing, cause well, we definitely have some, you know, like signs of correct interrupt, but it's definitely not ideal. So next video we're probably gonna fix that bug, find like what does this problem means. So I just monitored it and here what it says. It says like abort was called at some address on core 0, so probably should fix it. Yeah. So tomorrow we're gonna fix it, and I hope you enjoyed this, guys. So if you enjoyed, like, hit the like, subscribe, leave a comment. I don't know, leave a comment like what do you like, what do you maybe learned from this video, because I guess this video was pretty useful. You can also check the previous series where I explored the interrupt theory in general, so how it works. Uh, there wasn't any code there, but I was just exploring how it works on the hardware level. And yeah, see you tomorrow, guys. Bye.